Well, hello Internet, and welcome to my C++ programming tutorial. In this tutorial, I'm going to teach the entire C++ programming language in one video. In the description underneath the video, you're going to see links to all the individual parts, so that should help you get to exactly what you want. And I'm not going to waste any time covering installation. If you guys want me to cover that, just leave a comment down below, and I'll do that later. So I have a lot to do, so let's get into it. Okay, so what I have here on the left side of the screen is a basic text editor. What I have here on the right side of the screen is a terminal. Everything's going to be exactly the same as long as you use G++ to compile your programs, no matter if you're on Mac, Windows, or on a Linux operating system. So the very first thing we're going to do here is cover comments. This is a comment. Just like many other languages, you can create a comment just by putting two dashes and then whatever you want. And if you want a multi-line comment, you can just type in multi-line and then close that off. So there is commenting in C++. First thing we're going to do here is include some outside libraries. We're going to have some functions that we're going to want to use. So this one's going to allow us to use a function called cout and a whole bunch of other different things you're going to see here in a second. That'll be used for vectors. This will be used for strings, and then this will be used for file I/O. Now all of your code is going to be contained inside of a main function like this, and then you're going to have a curly bracket, and then you're going to have a closing curly bracket. Now inside of here, you could call the function cout either using cout or std cout, like this. What I want to do is get rid of this part, and how I get rid of that is right here, right after the include statement. So I'm going to type in using namespace st. And that's going to keep me from having to type that out every single time. Now if you wanted to do a basic hello world type of statement here, all we're going to have to do is type in hello world using cout, which outputs the text that we have here, and a carriage return whenever we type in the same brackets you see right there, and end L. That's for the carriage return, and this right here is saying we want to output this on our screen. The other thing we'd need to do here is call return 0. You're always going to do this, and 0 stands for the execution went through perfectly fine. So just to keep everything simple. Jump over here in the terminal, and this is the command I'm going to use to run this. It's called ctut, and make sure with your C++ programs you always end them with cpp as the extension. And then right here I'm saying that I want to use the version 11 of C++. Then I'm going to compile that, and then to run it I'm going to put /a.out. And if you're on Windows, you would just type in A, and you can see hello world prints out right like that. So the next thing we want to discuss here are variables and data types. Now variables start with a letter and can contain, of course, additional letters, numbers, or underscores, but they must start off with a letter. And here we're going to actually create a constant variable, which is going to be of type, data type, double, which means that it contains floating point numbers or decimal places. And here we're going to give it the value of 3.1415926 535. And once again, constant being here just means that this value cannot be changed, and normally whenever you define constant variables you make their names in all upper cases. Other data types that are available to you are characters, which contain just one character, and they are going to be surrounded by single quotes. So let's say I have a grade equal to and A, right like that, and there you go. And a character very specifically is going to take up 1 byte inside of memory. Booleans, which normally start with is whenever you're defining the variable name, can contain true, which is going to be comparable to 1, or false, which is going to be comparable to 0. Ints or integers are just whole numbers without decimal places. Floats are floating point numbers just like doubles, and they normally are accurate up to 6 decimal places. Let's just say favorite number and just copy this guy. And doubles, of course, like I said before, are also floating point numbers, but they tend to be accurate up to around 15 digits in length. And then of course if I want to output one of these variables on the screen, I'm going to use cout again, and then I could say favorite number inside of double quotes, and then to output it I just put another bracket inside of there, favnum, and then of course end L for a carriage return, and there you can see favorite number 3.14159. Now, of course, there are other data types that are available. We have short ints, which are going to be at least 16 bits in size, long ints, which are going to be at least 32 bits, long ints that are going to be at least 64, unsigned ints, which are going to be the same size as the signed version, and long doubles, which are not less in size than regular old doubles. If you want to find out the number of bytes for a data type, we could come in here and go cout and say something like size of int. We could then call up size of, and put my age inside of there since it is an int. And inside of C++, all statements end with a semicolon, so we could just jump down here, keep everything on the screen, and go like that. Compile and execute. You can see right here, size of an int is 4 bytes. If I would then go in, do exactly the same things for characters, booleans, floats, and doubles, and execute, you can see how many bytes are in each one of those as well. If you're wondering how big a number can be based off of bytes and so forth and so on, let's go in here and let's create the largest int that we can possibly create. And whenever we know the fact how many bytes an int can contain, we can then go in and define exactly how large that number would be. And you can see right here, this is the biggest integer we could possibly have. And if we went down here and said, hey, let's go and output that like this, and you can see it prints out exactly the way that you would expect it to. However, if we go 1 over and put an 8 in there instead, and save that, and recompile, you're going to see that you get completely different results. See, it comes back as a negative number. That's just a demonstration of what happens whenever you go outside of the bounds using your different data types. When it comes to arithmetic, you're going to be able to use plus and minus and multiplication and division, as well as modulus, which is going to return the remainder of a division. And we're also going to be able to use shorthand incremental notation as well as decremental. Give you an example of what that looks like. You can see right there on your screen, and exactly how you would perform addition if you wanted to output that on the screen like this. And to demonstrate the shortcuts for increments and decrements, let's say that we have an int, and I'm just going to call it 5 and give it the value of 5. Then output on our screen, 5 plus plus is equal to, and then take the variable 5 and increment it. I'll then increment it from the left side, and then I'll decrement it from the right side, and then I will decrement it from the left side. And you can see what's going on right here. In this situation, whenever you increment from the right side, it is going to actually perform that action after it gets the current value of 5. That's the reason why you see 5 here. Then over here, whenever you increment it on the left side, it is going to increment it first. Remember, it currently has a value of 6 because that's what happened up here, and that's the reason why you get a 7 over here. And likewise, whenever you have decrement on the right side, it occurs after the value is taken here. And then here you see that both of them are decremented, and we're back at 5 again. We'd also be able to come in here and use another form of shorthand assignment notation by going 5 plus or equal to, and let's say 5 in this situation. That right there is going to be equivalent to if you had 5 is equal to 5 plus 5, right like that. Or let's change this into 6 so it's not quite so confusing. And yes, you could put multiple statements here on the same line just as long as you have semicolons. That's how C++ defines that a statement has ended. Another thing that's important is to understand order of operation, in which basically it states that if you have some calculation that's being performed, the multiplication and division are going to be performed before any addition or subtraction. And you can see right here exactly what we're doing. Here I have braces around the additions and subtractions, and up here I do not. And here if I execute, you can see I get dramatically different results. Why is that? Well, in this situation, we are going to have the multiplication occur first. That's where you're going to get 6 right here. Then we're going to jump in and have this add up to 3, which comes to -3. In this situation, we're going to perform addition and subtraction first, which is going to give you a value of 0. So when that's multiplied times 2, you're going to get 0. So use braces all the time. It's going to save you a lot of hassle. Now let's say we come in here and we want to show some division here on our screen. And this is exactly how we would do that. 4 divided by 5. However, if we execute that, we might not get the result we were looking for, which in this situation comes out to 0. What happens whenever we want to actually show a floating point number here with decimal places instead of basically just coming out to 0? It's actually very simple. Just come in here and we're going to perform what is called casting. To cast from any of the different data types, you're going to take the type that you want to cast to, put it between these parentheses, and you can see here, if we now compile and execute, you're going to get exactly what you wanted. And of course, these can be performed by putting int inside of here to cast to an integer, even though that's exactly what it is, characters, as well as doubles, right like that. Now you can get rid of all this stuff here so that we can focus in on the if statement. Now the if statement is just basically going to execute different code depending upon different conditions. You're going to have comparison operators, which are going to be equal to, not equal to, greater than, less than, greater than or equal to, or less than and equal to. You're also going to have logical operators, which are going to be and, or not. And they're going to come in the form of and, or not. So let's go and take a look at some examples of how we could use these. Let's say that we create an age which is equal to 70 years old, and another age at last exam. Let's say we want to set up a little program here that is going to define if a person is going to be able to drive or not. And then we're going to have is not intoxicated, and we're going to set that to true. Always a good thing if you're going to drive. Now we're going to come in here with our if statements. We're going to say something like if the age is greater than or equal to 1 and there's the logical operator. Make sure you close all the brackets off the right way. Age is less than 16 in this situation. Well, in that situation, we're going to say that they cannot drive. Now, if we want to check another condition, we're just going to type in else if. And in this situation, let's check to see if they're intoxicated. In this situation, we're going to use the not symbol, and we're going to say is not intoxicated. And all that's going to do is take this true right here, the not in this situation, and turn it into false. And in that situation, we're going to say you can't drive again. I could also come in here and do an even more convoluted thing. If, and I could say something like age is greater than or equal to 80, and then do another completely different comparison. Age is greater than 100, or, more brackets here, age minus age at last exam, and then close that off, greater than 5, and then close these off. So what I'm basically saying here is if the person is over the age of 100, we're not going to allow them to drive. If they are going to be over the age of 80 or equal to, we're basically going to require them to take an exam every 5 years to verify that they are actually still able to drive. It's kind of a convoluted example, but I'm just trying to find a reason to be able to come in here and show you how all these different things work. And in that situation, we're going to say that they can't drive. And then finally, for everything else that isn't checked, if we want them to have the ability to drive, if they make it the whole way down here, we're going to just type in else. And there you go. You're going to see that that works for you. And here, if we execute it, you're going to see that yes, indeed, this person can drive. So that's a pretty convoluted example of how to use if statements, as well as else and else if. Now let's take a look at the switch statement, which is basically going to be used whenever you have a limited number of possible options. So let's say we have int greeting option, and let's say they chose 2. Then what we're going to be able to do is check the versions or the values of greeting option with our switch statement, put it inside of curly brackets again, and we're going to say case if the value of greeting option is equal to 1, well then we're going to say that we want to print out on the screen bonjour. Then, to jump out of the switch statement altogether, we're going to type in break. And if you didn't check that, it's going to continue to check all of the other possible values, like it will jump down here if you don't have break inside and check to see if it has the value of 2. So you want to make sure the break's in there. And you could have hola and all those other different options. And then finally, with the switch statement, if you want to have a default thing that it's going to do, if none of the other things match, you just type in default and then cout and hello, right like that. Don't need break here in this situation. And you can see based off the fact that they did enter a 2 here, that hola prints out on the screen. That's basically everything you need to know about the switch statement. Now we'll take a look at the ternary operator, which is going to perform an assignment based off of a condition. And its basic format is going to be variable is equal to. There's going to be a condition here, followed by a question mark. And this is the value it's going to be assigned if it is true. And this is going to be the value that's assigned if it's false. And to show you a real example, let's say we have integer, largest num. And in this situation, I'm going to use real numbers. We're going to have our condition, is 5 greater than 2? Put our question mark. If it's true, then we're going to assign the value of 5 to largest number. And if it's false, we're going to assign the value of 2 to that number. And then, of course, we could print that out on the screen. So that's simple, ternary operator. Now let's take a look at arrays. Now arrays are just going to store multiple values of the same data type. So let's come in here and provide our data type for our array. Just think of arrays like boxes, because that's basically what they are in memory. So let's have an array here, and you have to define inside of arrays how many boxes you need or how many pieces of data you want to store in them at the very beginning, and then this cannot be changed. We'll look at vectors later whenever we want to look at a way to change those values. Could also come in here and let's say we want a array full of bad numbers, and it's also going to need 5 spaces to hold these numbers. This situation, we could come in here and type in all these numbers that we want to store, right like that. You're going to be able to get the first item in the array with a label, and the labels for all of these array items are going to start with 0, so this is going to have an index or label of 0. This is 1, 2, 3, 4. And if we want the very first bad number in this array, we're going to type in 0, just like I said, and change this to bad nums. File and execute, you're going to see the 4 pops up because that has the index of 0. We're also going to be able to come in here and create multi-dimensional arrays, which is just going to be boxes of boxes. So let's say I wanted to have a character array that's going to be multi-dimensional, and I'm going to have 5 spaces in the first array that's created here and 5 in the second array that's created here. I could then come in and define that I want to store the letters for my name. We're going to use 2 curly brackets in this situation. Then we're going to close off that first with a closing curly brace and then open it up again. And here I can put my last name. Let me jump down to the next line so it's a little bit easier to see. And we're using characters here. Characters always use single quotes. Strings, as you're going to see later on, always use double quotes. And then finally, after we have all those in, put the 2 curly braces in there closing, and there you go. That's a multi-dimensional array. If you would then want to get hold of and print out the, let's say, the second letter in the second array, use cout again, second letter in second array. We would go my name in this situation, and we want to get the second one. Well, in that situation, second is equal to 1, and then the second letter in the second array, go right like that, and there you can see right there A pops up, which is exactly the right one. You could also come in and change the value in the array just by using its index. So we'll say my name, and let's say we want to get the first array, which is 0 in this situation, and the second letter inside of it, or the third letter in this situation, and we want to change that to E. No problem. We can then come in here and change this to exactly the same place. File and execute, and you can see here the new value is E, just like we set it right there. Now I'm going to leave everything here because I'm going to use it while I demonstrate exactly how the for loop works. Now the for loop just allows you to continue executing code as long as a condition is true, and you're going to define it with for. Here I'm going to give the data type for the value that I'm going to increment, and I'm going to give it the initial value of 1. I'm going to say that we're going to continue incrementing as long as I is less than or equal to 10, and then we'll have to increment it right here, curly brackets. And inside of the for loop we could go cout and just print all of these on our screen. And there you can see it printed out 1 through 10. Now we could also come in here and use our multi-dimensional array by stacking inner for loops. And we'll just go for, and integer j is equal to 0. We're going to use 0 here because arrays start off with a 0 index. So we're going to say while j is less than 5. We're going to continue to cycle through here. And then inside of here, we're going to put another for loop. Let's have this be k is equal to 0. K is less than 5. Increment the value of k. And then we can come in here and print out my whole entire name by just putting j and k inside of there. And then finally, see I didn't put the end L in there. After it's done going through the for loop, I could then come in here and put the carriage return in and execute. And there you can see it printed out my name. Remember I changed the E here, and then it went and printed the last name. And that's what it's simply going to do. It's going to go to the first array, cycle through everything using this for loop right here. Then it's come down here, and then J is going to come up here, and it's going to print everything out. So that's how for loops work. Now let's take a look at while loops. Now you're going to use while loops instead of for loops when you don't know ahead of time when your loop is going to end. So let's say we have a random number, and this is how you would generate random numbers inside of C++. We go rand, and let's say that I wanted to get random numbers between 1 and 100. Put modulus 100 like that. Now this guy alone is going to generate random numbers between 0 and 99, so if I want 1 to 100, I'm going to put a 1 right here. Now with a while loop, I can say that I want to continue cycling through this loop as long as random number is not equal to 100. And we could print out on the screen the random number every single time. And in this situation, let's say we want to put a comma between there, close that off. But of course, you're going to need a way to get out of this while loop, so the random number is going to have to change. So go and generate another random number. Make sure we use the same thing again. And then after we are done with our while loop, put a carriage return in there. Oh, don't forget to put the equal sign in there. And now let's go and see how long it takes us to get to 100. And there you can see it, printed all those out right there on our screen. And I don't know, I'm not going to count how many of those are, but it didn't take that long to come up with a random number of 100. Another thing that's kind of interesting is you can basically simulate exactly what a for loop does using a while loop. The only thing is we're going to have something that's going to increment for us. This index right here will do fine. And in this situation, of course, keep it outside of your while loop, just like we did with our random number before. And we're going to say that we want to cycle through as long as index is less than or equal to 10. And then inside of here, output the value of index, and then of course increment your index right here. And you can see you can do pretty much exactly the same thing you can do with a for loop with a while loop. And that brings us to do while loops. and they're going to be used whenever you want to execute whatever is in the loop at the very least one time. And I'm also going to talk about strings here for a second, because we're now going to also cover how to get user input. I'm going to create a string, which is just a series of characters. That's all a string is. Int, number, guessed. Give this value of 0 to start off. And then the do while loop is just going to start off with do. And then in the very end of it, we're going to have the while part. So you know everything is going to be executed that is in the loop at least once, even if int number guessed is not equal to 4. So int number guessed is not equal to 4. And this is going to be a basic like guessing game. And you have to put a semicolon here at the end. Don't forget that. Now inside of this, we're going to get some user input. We're going to start off by saying that the user of our program is to guess a number between 1 and 10. We want to allow our user to enter some input, and to do that we're going to type in get line. We're going to type in CIN, which is going to be the source of the user input, which is going to be the keyboard in this situation. And then we're going to have to say where we want that value to be stored. In this situation, we're going to store it in the string number guessed. If we want to convert the string into an integer, we can then go int number guessed. We need to do this because this guy right here, we're not going to be able to compare a string to an integer of 4, but it's easy enough to change. We're just going to type in stoi, which is going to convert a string into an integer, and then we'll pass in number guessed, which is our string, and then we could print int number guessed if we would like, and this is going to continue to cycle until they enter the number of 4. And then if they get out of our do while loop, we could come in and go cout, you win. Otherwise, it's going to continue to ask them. As you'll see, guess between 1 and 10. I type in 1, ask me again, 2, now 4. You can see I won. Alright, so there's user input converting from strings into integers, do while, and a whole bunch of other different things. Now let's take a deeper look at strings. Now in C++, in comparison to C, C++ is going to provide us with string objects. And like I said before, they are always going to be surrounded with double quotes. And just to cover this real briefly, inside of C you would have previously made strings by saying something like happy array 6 like this is equal to, and then created a character array. So just type in happy, and then you had to always end it with a backslash, and then a 0 with a closing curly bracket, and that's how we were using strings inside of C. The C++ way is much better and easier. So we're going to say string birthday, string is equal to, space in there, birthday. And there we are, we're done. Now we could of course combine these guys, and how we're going to combine them is with a concatenation operator, or just a plus sign, or you can just call it combined. You can call it whatever you want. So birthday string, and there you can see it printed happy birthday. Combine both of those, print them out the screen, and perform a couple other different operations. Let's say, let's call this your name. Always need to define your variables before you use them, and then I'm going to have it come in and print out the screen to get you some user input. What is your name? Get line, it's going to get the user input, get it from the keyboard, store whatever they enter into your name, and then I could go cout, hello, put your name inside of there. What's your name? I could type in Derek. Hello Derek, talks to me. Could then come in and create, let's say, a double in this situation. Euler's constant. If you don't know what this is, don't worry about it. It's just a random number I thought of, or Euler thought of actually. I could then go string, Euler guess. If we wanted to do like a little quiz application, get an uppercase letter right there. Just makes it easier to be able to read the variable names. And then I'll go Euler guess double, and now I'll come in here, ask them what is Euler's constant. I could then get whatever they enter inside of here, and don't worry about it. I'm going to show you how to convert from doubles, or from strings to doubles. All you need to do to convert from a string to a double, and we're going to store it in Euler guess double, is type in, instead of STOI, STOD, right like that. And Euler guess is the string value they entered, and then I'll say if Euler guess double is equal to Euler constant, which you can see all those on the screen, curly brackets again, cout, you are right, and then else, you are wrong. Make sure you come in here and put an S inside of there. Euler's constant, Euler's constant. Execute, what's your name? Derek. What's Euler's constant? 0.57721. You are right. You can see exactly how that works. A couple other things we can do with strings. If you want to get the size or the number of characters in a string, cout, size of string. Could use Euler guess in this situation, and then just call size. So it's basically exactly what you thought it would be. Want to check if a string is empty, Euler guess again, and just type in empty. It's great to use whenever you want to test input from a user. Could use append also to be able to add strings together. So we could get Euler guess and call append and then add something like was your guess. Bounce out of there. There you go. Derek, 0.5. Let's type that in. You were wrong. Didn't matter. Size of strings equal to 3. See right there. Decimal 5. That's the 3. Is string empty? 0 comes back or false. Well, it's obviously not empty. And then it prints out my guess there on the screen. Come in here and create another string. Let's call this dog string. Give it the value of dog. And cat string. Give it the value of cat. We can compare numbers. So let's say I wanted to see out, or compare strings with the comparison function. And let's change this to dog, and this to cat, and change this to dog. And you can see in this situation, whenever a value is equal, like it is here, dog string and dog string, you're going to get a return value of 0. You're going to receive a 1 in this situation if it's less than, and a -1 if it's greater than. And this is all based off of alphabeticals. So we could also come in here and assign copies of a value to another string. We could go whole name is equal to, and go your name, assign, and I could say your name, and there you go. I could then get a substring. So let's say that I wanted to get the first name. Well, I would go whole name like that, dot, assign, and I would pass in the string I want to work with, then the starting index from which I want to first start pulling characters, and then the number of characters I want, which is 5. I could then come down here, change this to first name. If I typed in my full name then, you're going to see that it just grabbed the substring of Derek. I could then perform a search on a string. So let's say that I wanted to find the index of my last name. I could get the last name index. If we did not know it, I could type in your name and then find, followed by the substring that I want to find inside of there, and the index that I want to start searching from. And then I could say index for last name index. There it is, my full name, and you can see the index starts at 6, and if you count over, you're going to see that B actually is 6. And also insert is going to allow me to put in a string at the index that I tell it to put it in. So I'll go insert 5, so starting in index 5, I want to put in the word Justin. Change this to your name just so you can see that here in a second. I could also erase or delete 6 characters starting at the index of 7. And I would just go your name again, the string I want to work with. Erase, starting at 6. I want to delete 6 characters starting at the 7th index. And then print it out there again. And then finally I could also come in and replace. Let's say I want to replace 5 characters starting at index 6. Well, there's the index 6. I want to replace 5 characters, and let's say that I want to change it to Maximus. So my new name will be Maximus. And make sure that is name, your name. And here's my name. And you're going to see all the changes that are made to it. Right there I inserted Justin inside of there. Right there I got rid of it. And then right here I performed a replace to change my last name to Maximus. So there is a lot of stuff about strings. Okay, now let's talk about vectors. Now vectors are just like arrays. The only real difference is that their size can change. And how you create a vector is type in vector and then the data type you want to store. And then let's say that I want to store lottery numbers in my vector. I'm going to decide that the initial size should be 10. I could then create an array to show you how to put an array in a vector. And let's say it has a size of 5. And then we'll initialize it just like we did before. 14, 24, and 34, like that. We can then go and take our vector and insert our array. And how we're going to do that is go lottery number vect and say that we want to start inserting at the beginning of our vector. And then we'll say the array that we want to insert into it. And then let's say that we only want to take the first 3 numbers from our array. Right, like that. We could then go cout and just print lottery num vect like that, and at, and let's say we want what's the third item, which would be second index, whoops, like this. We want to output that on the screen, because remember, it didn't take the whole array, it just took these first 3 numbers. And there you can see 14 popped up. Now if you would want to also come in here and let's say we want to add another value into the 5th index, lottery num vect dot insert. We could then go lottery num vect dot begin, which is the beginning of the vector, plus 5 to get to the 5th index, and then put 44 inside of there. We could then jump down here to 5 and see that 44 popped up. Pushback is going to add a value at the end of our vector. So pushback, and let's say we want to put 64 in there. If we then wanted to find As you can see, the vector resizes. We then wanted to find that final value. We could call back, and it would get it for us. As you can see right there, pop back is going to remove the final value. Well, there's no point in doing that, which in this situation would be 64. And then we could get the first value in the vector by calling front instead of back. We could get the last element by calling back, of course. Empty is going to return 0 if the vector is not empty, and a 1 or true whenever it is empty. And then finally, if we wanted to get the size of our vector, we could do that with size. So there's a rundown of all we can do with vectors. Now let's take a look at what we can do with functions inside of C++. Now your functions are actually going to appear before your main function, and it basically just has the return type. So let's say that we wanted to have a function that added numbers. We would have our return type for our function. If it didn't have a return type, it would have void instead of integer. And then we're going to define the data types for our attributes that are going to be received by our function. Second num. We could also set it up so that this function would have a default value, which means actually you wouldn't have to send a second attribute in that situation. The only thing that you have to do is, if you do this, is all of your functions that have a default value, or all of your attributes that have a default value, have to come last. So this has to come before that. So that's the only rule there. And this is also known as a function prototype. We could then go and type in combined value is equal to first num plus second num, store that in there, and then return the combined value. And I did it this way so that I could demonstrate something else. You could take this right here and put it right down here in the return part right there. You don't have to create a new variable just to perform that. Another thing I want to demonstrate, since I'm up here and not inside of main, is that you are able to overload functions, which basically means you can use exactly the same name but different attributes. So I could come in here, even though I have add numbers already. Actually, let's just copy the whole thing, paste it in there. So there's add numbers twice. It's okay to have add numbers. The only problem is we have to have different attributes inside of here. So let's say we have second num, and we also have another integer, which is going to be third num. And like I said before, we don't need all that. We could just go return and perform our addition right inside of here. Second num, third num, and return that. Now let's jump down inside of main and actually call these functions. If I didn't mention before, functions basically allow you to reuse code and also add a certain level of organization to your code. So here, add nums, I'm passing in 1. I'm going to use the default value of 0 there. Not going to pass anything in, just to demonstrate it. And then I'll show the other one as well. Add numbers, 1, 5, and 6. Endel. You can see if I execute that right there, you got 1 and 12 pop back on the screen. Let's go and create a little bit more complicated function here. And this is basically what they call a recursive function. And this is normally demonstrated using the getting of factorial. So that's what I'll do. Get factorial, int, number. And this is going to be a function that calls itself from inside of itself. Sounds way more complicated than it is. So I'm going to go and create an integer called sum. Then I'm going to say if number, which is going to be passed inside of here, is equal to 1, then I want to have sum equal to 1, else sum is going to be equal to get factorial, see, calling itself from inside of itself. And here I'm going to go number minus 1 times number. And this is going to get our factorial, because here we're then going to return sum. So a very quick way to get the factorial of a number. And basically what is going on here is right here, we'll come down to this part. This is the first time through this function. And let's say number is equal to 3. Well, in that situation, get factorial is called with the value of 3. Well, it'd actually be 2. Let's just focus in on this one right here. So 3 minus 1 is equal to 2. In that situation, it's going to return a value of 2. And then we're going to multiply that times 3. So right here, whenever we're going through here the second time, this time we're going to be passing 2 into the get factorial. So there we are. And 2 minus 1 is going to be equal to 1. And in this situation, this is going to return the value of 1. And get factorial in this situation, whenever it comes in here the third time, number is going to be equal to 1, so sum is going to be equal to 1. And that's going to end that function's execution. And it's going to sort of ricochet back up to the beginning. So what we're going to be left with in this situation is this is going to return 1, which is going to be multiplied times 2. That 2 right here actually goes right here, and then we'll multiply that 2 times 3, which is going to give us our final value of 6. And let's go through here and let's actually run it to make sure that that's what it does. And how to find out is to go factorial of 3 is, and then call the function. Get factorial, pass in the value of 3, end L. Make sure I come up here and have the return value be an integer right there. And then also come in here and remove this little parentheses I put in there by accident. And if we execute it, you can see factorial of 3 is 6, exactly like we demonstrated up here. So there's a rundown of functions inside of C++. Now I want to cover file I/O, or how to read and write files using either text or machine readable binary. So I'm going to create a string here. I'm going to call this Steve quote is equal to, and I'm going to say a day without sunshine is like, night. Now what I'm going to have to do is create an output file stream to create this file if it doesn't exist, or what it will do is create a function or create a file if it doesn't exist. And I'm going to call it writer, and I'm going to define the name that I want to save this text into, and I'm going to call it Steve quote.text. I'm then going to verify that the file stream was created so that I'll be able to write to the file. If not, I'm going to put out an error message, and then if we want to signal that an error has occurred, we can return a -1 in this situation. Else, if the file stream is open, that means we can write to the file, and it's very simple to write text to the file. Just go writer and the string you want to write, and then I'll throw a new line on there at the end. And then very importantly, you also want to come in and close that file stream at the end. And I'm going to continue going here because we got to read from it. Let's say that you also wanted to come in here. Our file stream's closed, so we're going to create another one, and I'll just call this writer2. And then in this situation, what we're going to do is we're going to define that we want to write to the Steve quote text file, and then here we're going to say that we want to append what we're going to do next to the end of what's already there. Now there's a whole bunch of different symbols we can use here to do different things with files. Like I just said, with iOS app, we're going to be able to append to the end of the file. With iOS binary, we're going to be able to treat the file as if it's binary. iOS in is going to open a file to read input, which you're going to see here in a minute. iOS trunc is the default, what happens whenever you don't use one of these symbols. And then iOS out is going to open a file to write output. But in this situation, we're going to be appending. And once again, we're going to need to come in here and check that this file stream is already open. And I'm just going to copy this, paste that in there. Make sure this is writer up here instead of write. There you go. And this is going to be writer2. We're going to spit out an error again if the file stream was not opened. And then to append in this situation, we're going to go writer. And then let's say that we want to put on a new line, \n, and then a dash, and then type in Steve Martin. We then could come in and say writer close, and there that is. Alright, so we wrote and we appended and we created the file and did all that. Now I'm going to create a character that's going to hold each of the individual characters we're going to read from our file, and we're going to read these characters using an input file stream. So input file stream, and I'm going to call this reader, and you need to tell it exactly what file you're going to be reading from. And then I'm going to check if that stream is going to be open, just like we did before. Put the reader inside of there, come in here and print an error again, return error code -1. Else, we know that we got our stream open and we'll be able to read from that file. And we're going to use a for loop in this situation to read each character from the stream until we get to the end of the line. So I'm going to go int I is equal to 0. Then I'm going to go while the reader does not get to the end of the file, we're going to continue reading characters, and then we'll call reader get to get the next letter of output that we want. And then in this situation, let's just say that we want to print that out to the screen, type in letter. Then after the for loop's all done with, you go cout and del, and then once again close the reader. If we did that all right, day without sunshine is like, night. So you can see it worked out, and those are all the different things you can do in regards to reading and writing data using C++. I'm going to briefly touch on exception handling, and exception handling basically allows you to avoid potential problems. In this situation, I'm just going to focus on one, which is a division by 0 error that could cause all kinds of problems. Now, whenever you want to cover something that could cause an exception or an error that you want to be able to catch, you're going to surround the code that could potentially cause that error inside of what's called a try block. And then what we're going to do is we're going to have an if statement inside of here that says if the number is not equal to 0, well, in that situation, we can say cout and divide by number, like we have there. But as we can see, that is going to cause an error, and we're never going to get there. Else, we're going to say throw number. Now, this throw is going to look for a catch, and the catch area is where we are going to catch the number that was entered. Don't have to do this, but it helps. so that we have the error message make sense. And then we could do something like number is not valid, and then maybe have them ask them for it again. You can see here if we run, 0 is not valid. So instead of causing an error right here by putting this inside of a try block and then throwing if they would actually enter a 0, which causes potential errors, we're instead going to catch it down in this area right here and solve it and keep our program from crashing. So that's a brief explanation of exceptions. Okay, now let's talk about pointers. Now when data is stored, it is stored in an appropriately sized box that is based off of its data type, just like we covered previously. Here we have an integer and here we have a character. Now, like we did before, we're going to be able to come in here and use size of to determine how many bytes that data is going to take up. And we can see here whenever we run the program that the integer is going to take up 4 bytes and the character is going to take up 1 byte. Now you're going to be able to reference this box or this memory address where all of your data is stored with what is called the reference operator, which is an ampersand. So we could come in here and go cout, and my age is located at, and then use the reference operator followed by my age. And when we execute that, you can see the memory address right here. Now what's really cool about this is whenever we don't use pointers or we don't use reference operators and we change a value of a variable in a regular old function, that change of value does not carry on. It is lost. And the reason why is whenever we use regular functions, what we are in essence doing is passing a value into that function. So even if we had, let's say, add these, and we passed in sum as a variable into a function called add these, just like this, what's going to happen is the value of sum, so let's say we have an integer here, integer sum is equal to 5. And we pass sum into the add these function. Well, if we change the value of sum and we do not pass it back, sum is still going to be equal to 5 because we are passing a value. With the reference operator and with pointers in general, what we're going to be able to do instead is pass by reference, and any change that is made inside of there is going to show. Now a pointer is going to be able to store a memory address. Let's recreate my age to demonstrate this. And whenever you're defining a pointer, you just have to use the same data type followed by a star, and we'll say age pointer like this is equal to, and then you're going to use the reference operator to pass that over. Just like before, we're going to be able to access the memory address with this pointer of pointer by just typing in age ptr, but we'll also be able to dereference to get the data at that memory address. So we'll say data at memory address. And how you dereference is to put the star in front of age pointer, right like that. You'll see here with this pointer, we'll now be able to get the memory address as well as the data that is stored at that memory address. Let's take a look at arrays as well. Let's say we have our bad numbers array, just like we used previously. We can then go int star to create a pointer, and we'll call this number array pointer is equal to bad nums. What's neat here is we're going to actually be able to increment through our array just using shorthand notation like plus plus and minus minus. So we can go cout address number array pointer and value, and then to get the actual value in the array we can go num array pointer and then close that off, and then come in and go num array pointer plus plus to get the next value in our array. Bounce that in there. And there you can see, jumped in there, grabbed 4 and 13 as well as the memory addresses, and as we saw previously, an integer takes up 4 bytes. You can see the difference in the memory addresses right there. So you're learning about how this stuff is stored inside of here. And something else that is interesting is an array name is just a pointer to the array. So we could come in and go address and put the array name by itself inside of there, bad nums, to get the value that's stored there, and you can see that it works also. See, same memory address, same value. So something interesting to think about. Now, like I said previously, whenever we pass a variable to a function, you're passing by value. However, whenever you pass a pointer to a function, you're actually passing a reference that can be changed. So let's jump up here and let's create a function to demonstrate exactly how this works. This isn't going to return anything, so I'm going to put a void inside of there, and I'm going to say make me young. And this is going to receive a pointer. So I'm going to put int with a star after it, and then age like that, and then let's pop out here on the screen the previous age. I used to be like that, And to get the value of age, I put a star in age, because otherwise it's a memory address. Have to put that star in there. But then I can also go in and change that value by putting star and age is equal to 21. Don't return anything, don't have to do anything otherwise. Then I can come down here and call make me young. And if I want to pass a reference to that guy, passing by reference, that's all that means. I can do that. And then I could put I'm, and then just to check or verify that it actually changed that age, I can do this. And you can see, I used to be 39, that came from the function, then we changed it to 21 inside of the function, and then you can see here that it changed globally. You can also come in here, and once again this ampersand is going to denote that age reference will be a reference to the assigned variable. So there's a reference, the difference between a reference and a pointer, which I'm going to get more into when you should use one and when you should use another one. Then we're going to be able to go see out. You're actually going to use references more than you use pointers. Like I said, that's coming in a second. Another thing that's interesting is we could take this reference and increment it and see that that also changed my age, right like this. You can see, here's my age at 21, here's my age at 22. Again, globally, we're changing all of those. Then let's create another function. This one's going to be called ActYourAge, just to pass the reference and show the difference between passing that reference and dealing with pointers. Come up here and create another function. It's also not going to return anything, just to prove that nothing's exchanging hands. ActYourAge, except we're passing a reference this time, so we're going to put the ampersand inside of there, and I'm just going to put age there again. Doesn't matter what I put. And then here I'm just going to say age is equal to 39. Come back down here again, just demonstrating the difference between passing by reference and passing by pointer. And we could go in and prove that it still changed. Age is equal to NL. And there you can see it did indeed change. So basically you might ask yourself, well, whenever you're deciding whether you want to use pointers or references, when should you use which? Well, basically you should use pointers if you don't want to have to initialize at declaration. What that means is, you can see right here, I am defining or initializing what I'm referencing whenever I am using the reference option. Whenever I am dealing with pointers, I do not need to immediately initialize. And then on top of that, with a pointer, I'm going to be able to assign another variable to it. So a pointer is going to be able to deal with more than one, while a reference is going to get this one reference to this one variable and be stuck with it. So if you don't need to be able to change whatever you're going to be pointing at, use a reference. That's pretty much the ironclad rule. And that's the basis of pointers. We're going to get more into them here in a second, but now I'm going to jump over and talk about classes now. Now, in object-oriented programming, what we're trying to do is model real-world objects like an animal in code. And how you do that is you think about, well, what makes a specific object an object? Well, each object has attributes such as height and weight and whatever, and it also has capabilities. So it can run and it can eat, just to be really simple there. Well, these attributes are going to be modeled in the variables, and these capabilities are going to be modeled in the functions or the methods. Same thing, just a different name. So what I'm going to do here inside of my class is I'm going to have some of these things be private, and by private, what I'm saying is that anything that is marked private in regards to attributes or variables is only going to be able to be changed by functions inside of my class. And we do that just to keep them protected, and this is called encapsulation. So I'm going to have my name, height, and weight all be private. And while I'm in here, I might as well talk about static variables. Basically, if you put static in front of something, all that means is that this variable's value is going to be shared by every object of type animal that is ever created. So let's say that I want to also keep track of the number of animals that are created from my class. Well, it wouldn't make sense that an animal would count. That's another reason why we have static here, because static variables also normally are attributes that the class object would not have. So we want to be able to count the number of animals that are created, but we do not want to actually have the animal type defined to be able to do it. And that brings us to public. Well, if we have variables that are private, we're going to have public methods that are going to be able to access the values inside of there. So we're going to have something like getHeight. There we go. And I'm actually going to just create this here on one line. And whenever this is called, it is going to return the value that is stored for my animal object to whoever calls for it. And we can also do the same thing with weight. And this is also encapsulation. We're keeping all of our data protected. And this is going to return a string whenever the getName function is called. And we can just go return and name, and there we go. But what we really want to do whenever we're dealing with encapsulation is protect the values that are going to be stored. So they might want to come in here and set the height, and let's say that we decide that we only want them to be able to enter a reasonable height. We could provide a check inside of here to verify that the animal height makes sense and otherwise discard it. But in this situation, I'll just keep this nice and simple. Also going to do exactly the same thing here for the weight. So weight, and let's have this be kilograms, weight, kilograms, and of course it doesn't matter if you put centimeters or kilograms or what you put inside of there. And set name, and we'll say animal name. Right now we have to have this be different from this, but I'm going to show you how to change that here in a second. Animal name right there, and everything else looks perfectly fine. And then we could also create another function inside of here. Let's call this setAll. And here we're creating a prototype of a function that we are going to declare here in a second. You're going to see it. And that's how we declare a prototype. Another thing we would want to have is a constructor. And what a constructor is, first off, its name is going to start with whatever the class's name is. And then here we're going to create a prototype of that. And this is going to be the function that is going to be called whenever an object is created. And so it will pass in the height, the weight, and the name. And the constructor is going to handle creating every object. If we have a constructor, we also should have a destructor, and it just has that little tilde sign there. Once again, this is going to be a prototype where I'm going to build or declare the actual one down below. And then let's say that we want to have another constructor that doesn't receive anything. And this is an example of overloading. And to overload a function, like I talked about previously, the name can be the same, but the attributes need to be different. So here we have two ints and a string. Here we are getting past nothing. There's also protected members. Whenever we're dealing with protected, what we're saying is that anything marked as protected is going to be available to members of the same class as well as subclasses, but nothing else. And we could also come in here and define a static method, and a static method is set aside because they are attached to the class and not to the object. As you're going to see, I'm going to show you in a second how to actually call for a static method. And in this situation, static methods also can only access static member variables, like this guy we have up here, right there. So we are going to have this method specifically be able to return the number of animals that are created. Here we go, and this time we're not going to do a prototype, we'll just have it actually do what it's supposed to do. There it is. And also finally we'll create a toString, which is going to print out all the information we have on our animals. Okay, so we went and we declared our class. After this little curly bracket, we're going to put a semicolon, and now we're going to declare everything. So the very first thing we're going to declare is our static number of animals, and how we refer to static variables is put the class name followed by these two colons right here, and then whatever the name of it is. Say it's tied to the class. It has absolutely nothing to do with the object itself. We can then define the prototype method for setAll. So setAll is right here. We're going to go and define it. There, that was just a prototype, and we're going to do that by putting void animal and then set all, like that. And then we have to define exactly what's being passed in here. So we're going to have two ints for the height and the weight, as well as the string name. This basically does what the constructor does, but just wanted to show you something. Now, if you want to refer to an object-specific height and not just a generic type of height, you put this inside of here. And the reason we have to do that is whenever the class is created, there are no animal objects created. So if we want to refer to the animals, the specific animal objects version or value for height, we have to put this in front of it, and there we go. And now we can also do the same thing for weight and also name. Just change this to weight and change this to weight. And we could have also come up here and used this here. See how we had to use centimeters instead of having height or weight or whatever inside of there? If we would have used this, we would have been able to get around that. Just a way to refer so that the code actually knows what you're trying to code or what you're trying to do. You can also come in here and change that static variable. Remember, we are creating or changing the values here. And then once again, we're basically going to do this with the constructor as well. And remember, the constructor is called every single time an animal object is created. So there we go. And it's going to be called animal. It's going to get this right here, int weight string name, and this is basically going to do exactly the same thing that this does. Let's just go in there, paste it in there, and you can see that basically setAll does exactly the same thing that the constructor does, so there's no reason to put that in there. I just did it just so I could show you another function inside of there. So let's just get rid of this to show you that regular functions and constructors all are the same. For the deconstructor, we're just going to go animal, 2 colons, ampersand, animal, doesn't receive anything, and we could come in here and just put a message out, animal, and we get the specific animal name, put this in there again, name, and destroyed, just so that we have a message on the screen to see what's going on. We have our overloaded constructor that's going to be called whenever no attributes are passed in. Again, animal, animal, it's still a constructor, no attributes, and in this situation we could also call that we have created another animal. Then we have the toString. Where's that at? There it is. See, just void toString. Let's come down here and declare that. Void, doesn't get anything. Animal, class name, toString, doesn't receive attributes. And here we could come in and just print out all the information that we have on our animal. Is, then get the height for our specific animal object. Jump down to the next line, just keep this neat. Centimeters tall, and this, get the weight for it, kilograms in weight, and just close that off. And then we'll be able to go down in main and start creating an animal object. So to create this, let's say we want to create an animal named Fred. We could then go into Fred and set his height to 33, set his weight to 10, and set his name, of course, to Fred. Right, like that. Just created a new Fred animal. We could then get the values back from it by going Fred dot get name is. We're not using this here, just to show you the difference between trying to get the data from inside of the class itself and then trying to get it somewhere else. Centimeters tall. And Fred get weight, kilograms in weight. And there we are. And we could also come in and use our constructor in this situation. Here we are using the default constructor that doesn't get any attributes, and here we'll use the constructor that does get attributes. So we'll pass in 36, 15, and Tom, and then we're going to be able to also print out all the differences between Tom and Fred. Let's print that out, and then just change this to Tom. There's Tom, there's Tom, there's Tom. And made a little error here. Let's just jump up to set name, and let's make sure we change this to a string and not an integer. Move a little bit too fast here sometimes, make little mistakes. And there's animal name. Let's also come down here and change this name and then change this to name. Alright, so there you go. Now you saw that we created a Fred and a Tom object. Let's go over and execute that. And there you can see Fred is 33 centimeters tall, 10 kilograms in weight. Tom is 36 centimeters tall, 15 kilograms in weight. And here you can see the destructor was called to destroy both those objects since we no longer need them. Now we can also come in and inherit all of the attributes and the methods that are created from the animal object, and instead use them in our dog class. So there we go. We just need to create a new dog class, and to inherit all the animal classes, we just put a colon and then public and animal. And that's all we need to do, and we have everything that is defined in the animal class. We could come in here, of course, and create some new ones. So let's say we wanted to have a sound string that is going to have the value of wolf. And then we could also come in and create a bunch of public methods that do some different things. One thing it's going to have to do is get the sound, and in this situation I'm just going to have that print out on our screen. So sound, there we go. Since we are going to have a sound in our dog class and our dog objects, we're going to have to declare a new constructor that's also going to get the sound. So int, string, and string, like that with that prototype. We could also come in here and declare a default constructor that's not going to receive anything, and then on top of that call the default superclass constructor, just like going like this, and there we are. And then we could also decide to overwrite toString, since we are also going to be printing out the dog sound. That's all we're going to do there, and then put another semicolon here at the end, of course, very important for our class. And now we have to go in here and actually define everything that is going to change. So this is going to be the constructor for our dog, and it's going to get past the int height and the integer weight and the string name as well as the string bark. Now to reference the animal class here, I'm going to put a colon, an animal, and we're going to say here that we want the animal constructor to handle the height and the weight since it handled it so well previously. However, I want in this constructor to be able to handle the sound part because sound doesn't exist in the animal class. And here we're just going to have it be bark. So that's a great way to have the animal constructor handle height, weight, and name because all those attributes are going to be shared and at the same time just change the thing that is different. Saves us some space. Also could come in here because toString also changed. So let's go in here and change it. And because the attributes like name and height and weight were private in animal, I'm going to have to use the get method to be able to access them. So I'm going to say this get name, right like that, is this get height, centimeters tall, and this get weight, kilograms in weight, and says, this is the thing that's different, jump down here, this sound. Okay, now I can demonstrate actually creating a dog object. So let's just go dog and let's call him Spot. We're going to pass in 3816. His name is Spot and the sound is going to be woof. If I also just want to demonstrate using static methods here, go cout number of animals that were created, animal, and to call a static method you go get num of animals. I believe that's what they called it. Find out in a second. And I'm also going to be able to go spot dot get sound, and we could also go in and get Tom test2string, which basically does what all that other stuff did up there. Spot dot to string. And just to show you one other thing, we could also call the superclass version of a method by going animal, spot animal, and then putting 2 colons and string. And by the way, I keep calling this 2 colons. This is called the scope operator if you want to know what that's really called. And of course, at the end here, make sure we put our return statement with 0. And if we execute it, you can see there's everything. Number of animals that were created, you can see it's 3 right there. And that includes Spot being the dog, as well as Fred and also Tom. So that's the reason why that showed up, and the reason why is the animal constructor was called every single time, whether a dog was created or animals were created. You can see wolf right here is this guy right here calling get sound. You can see we're calling toString on Tom to print out the information on that. We can see here that Spot also says wolf while the regular animal does not, and that automatically works. And here we're just demonstrating the use of calling toString, and in this situation Spot, whether he has a sound or not, doesn't matter because we are calling the animal version of toString, and the animal version of toString only prints out the height and the weight as well as the name. And then finally you can see right here where the destructors are called and all of our objects are destroyed. Okay, now it's time to talk about virtual methods and polymorphism. I'm going to hold off on the definition for polymorphism here and instead create a new animal class. And it's going to have some public stuff that it does. And what it's going to do here first off is get family, which I'm going to refer to as a family of objects. And there's, let's just say we are animals. Close that off. And then this is where we get to virtual methods. I'm going to mark this as virtual and then I'm going to change it back from virtual. Basically we mark a method as virtual when we know that an animal, in this situation, will be a base class that may have this method overwritten by a subclass. And you're going to see it in action here. It'll make more sense when you see it in action. So, in this situation, I'm going to say, get class, and then I'm going to go, I'm an animal. Okay, so these are all in the family of animals, but the specific class for this is animal in this situation. And close that off. And now we're going to create a subclass called dog of type animal, or it's going to inherit from animal, and it's going to have public, of course it inherits everything, get class, and in this case I'm a dog is going to get printed out, and then close off that class. Now what we're going to be able to do here is come down inside of here, create an animal class, it's equal to new animal, and dog in this situation, new dog. Now in this situation, it's not going to matter if this is marked as virtual or not, because these are both references to animals and dogs. As you can see right here, I can just go animal dash get class and dog dot get class, right like that. Here I got the virtual part off of there. And here you can see if I execute this, I'm a dog and I'm an animal, both print there on the screen. If I was, however, going to try and call get class from a function, you're going to see that we get some problems. So here we're going to say void what class are you? And we pass in an animal object. They're both animal objects, remember? Well, you would think I'd be able to go animal, get class, and get exactly the same results. However, as you're going to see, if I do that by passing in animal and dog, we don't get the results we expect. Instead, what happens is I'm an animal gets passed in both times. If we want to be able to call the proper get class for the dog and the proper get class for the animal, all we need to do is come up here and type in virtual. And all that means is it's saying, hey, we expect this to change, so if you get a dog, whether it's an animal or not, why don't you go take a chance and take a look at if get class resides in the dog class or dog object. And there you're going to see everything prints out exactly the right way. Now we're going to come up and create a couple more classes. Let's say that we also want to create another class, and let's call this German Shepherd, which is a little bit more specific. And it is going to be of type dog. And then we'll go in and type in public void and overwrite get class with I'm a German Shepherd, Endel, closing curly bracket, and void get derived I'm an animal and dog, Endel, closing curly bracket. And now come down here and experiment a little bit more. See, basically polymorphism, all it means is whenever a animal is passed in this situation, like it did right here, we passed in an animal object, it's automatically going to find the right method to call. So that's basically it. Now there's many ways you can apply polymorphism, but polymorphism on its own looks like that. So let's create a dog object, and then let's create a German Shepherd and call him Max. The base class can also call derived class methods as long as they exist in the base class. So we're going to come up here, create an animal, it's a pointer to the dog, and to get a reference to spot, we just put that little ampersand in there, create another one, and then point this to the German Shepherd. Get a reference to that with Max. We can now call the method that was not overwritten by any of the other classes. Get family, that's the same in animal. We could also call get class, which was overwritten, and then come in here, change this to void, sorry about that. And then of course also close off our class with the curly bracket and execute it. And there you can see, we are dogs. We were able to call this guy properly. And then I'm a dog. See, this is a reference to dog spot. And we were able to call the proper get family because this was listed as an animal. And also we were able to call the very specific class that resides in dog, even though these were listed as animals. Another example of polymorphism. Another thing that's neat is we can actually call the superclass, or German Shepherd, because everything is inherited. So we can call get family that resides in the animal class. And of course we can also call the overwritten German Shepherd version, Shepherd, and it's automatically going to go and get the right thing, as you can see right there. We are animals, and I'm a German Shepherd. So there's an example of using virtual methods, as well as a whole bunch of different examples on how polymorphism works. And then to finally get polymorphism 100% in your head, let's go and create an animal object, as well as a dog object, and a cat object that all inherit from the animal class. Now the animal is going to be a virtual method, again, because we're going to override it, and we're going to treat them as animals, because they are. Curly bracket, and we'll say the animal says ger. Basically going to do make sure you put that closing curly bracket on there. And then we're not going to copy the virtual part in this situation. In the dog here, we're going to say the dog says woof, and then the cat says meow. As homework, you could look into how you would actually set up an animal class as a capability class that exists only to be derived from. So look into that. There's your homework, because you guys ask for homework all the time. And now I'm going to also jump in here and give you an example of what an abstract data type looks like. So let's say we have a car, and this is more for completionist reasons than anything else. We could come in here and public again, virtual int get num wheels, the value is 0, and virtual int get num doors. And then you'd be able to derive this by coming in here and creating a new class called station wagon, inherit from car, even though car doesn't do anything, closing bracket, move that up, and then come in and define everything that we saw in the generic car, or the generic car abstract data type. Get num wheels has 4 wheels, like that. Close that off. And then we could go int get num doors, just like we defined up here in this abstract data type for car. Station wagon has 4 doors. And then we could also come in here and go station wagon, create an empty constructor and a destructor, right like that. Now let's jump down in main and play around with these guys. So we're going to create another animal here for our cat, and to do that we just call cat and animal dog, new dog, and we can see that if we call the cat specifically saying we want it to make a sound, and then we do the same thing with the dog, you can see that the cat says meow and the dog says woof, even though they're both set up as animals. And now let's go in and test our abstract data type with the car. Let's create a station wagon of type car. It's equal to new station wagon, right like this. And even though it is a car object, get num wheels, you can see that station wagon has 4 wheels, shows up there on the screen. So there's a whole bunch of different examples of polymorphism and a whole lot of information on C++. Hope you guys enjoyed this video. If you actually watched the whole entire thing, please leave a comment telling me so. I would really appreciate that. And please leave your questions and comments below. Otherwise, till next time.